All right. Hi, everybody. Thank you all for coming. I just want to give a quick thank you to Quality Bath for hosting the meetup, and to all the organizers, especially Ellie, for making sure that things run on time and don't end later than they should. We really appreciate it. I'm still traumatized. We'll go through it later. That's good. So everybody who's here, I'm sure over the last 6 months to a year, has been hearing a lot about AI.
Generative AI. It uses AI to bring AI.
What are we talking about?
Yes, I don't know. This was at Google I/O, so that was like before the AI craze. So let's go figure out what the big deal is about LLMs, AI, GPTs, all that fun stuff. My name is Tzvi Bell, as Ellie mentioned, but I'll mention it again because it's on the slides. I work at the tech team at CarCash, and although he's not here up on the stage with me, Yecheskel Hertz Ellie's cousin prepared to talk together with me, and we pretty much took off work for the last week to play around and experiment for this talk. This is kind of like work. So about 2 years ago, Ben Lam was working at CarCash. He's a big AI enthusiast, and he was showing Yecheskel and I the GPT playground, pre-chat GPT playground by OpenAI. And we were using it to help some of the sales guys write better emails. We started using it to create subject lines, help us with our marketing emails, create prompts to use Midjourneys for our baseball-themed beauty sale. You can talk to Yecheskel about the particulars. Do things like create an image like this. I don't know if you can really see, but it's really a GIF, and get it to create the same image in a few different color themes, and then stitch them together with Canva and use all their AI stuff. But what we are seeing is that we're able to do a lot of interesting things, certainly on the content and the marketing side with AI. And then when ChatGPT was released, when GPT-4 was released as a model, and then the custom GPTs, then we did a lot of very interesting stuff that we're still using today. Once we did that, we were trying to figure out, well, how could we use this on the tech and product side as well? So we started playing around and doing some experiments. And what we started asking is a lot of the basic questions when you start playing around with technology, like, are there any established patterns we can look at, any best practices? Are there any frameworks that are available? Let's see what the tooling's like. What are the security implications? We're at CarCash, we sell essentially cash on the internet. So we definitely have some concerns there about security. Any good APIs we could use. And what we realized is the answer is pretty much, nah, you're on your own. Generative AI is relatively new outside of academic circles. Pretty much since March 2023, when the ChatGPT API was released, you started seeing this huge explosion of tools around ChatGPT. So that is that. The goal of this talk is not to dig really deep into how LLMs work under the hood. I would be lying if I told you I understood it on a deeper level. That's A. And B, it's not that important to understand the intricacies of the low-level stuff. I will go over it quickly, and don't be concerned if you don't understand it. I will focus most of this talk on how things work and how to actually try to take some of this stuff to production. I am not an AI expert, but I went down a few of these rabbit holes as we were going through some of this stuff and trying to build things. So I figured to just share some of the details of our journey along the way. All right, so in 2017, researchers at Google, University of Toronto, released a paper called Attention is All You Need. That kicked off a huge wave of research and a lot of spent money trying to develop models and work off that research. And OpenAI was actually created before this, but they did a lot of work. They released a bunch of models. The green are just model releases. And probably the first interesting generative AI product that most of us use is GitHub Copilot in 2021. And then ChatGPT was released at the end of 2022, in November, hit 100 million users in, 10 minutes. And then I think that's where we're all in this AI, generative AI space. This winter, the Y Combinator batch has 245 startups. 171 of them, so 70%, are, yes, we're still in startup mode, are AI startups. So it just shows you like how wild, at least investors are, over AI. So it doesn't matter if you build anything good, as long as you get money for it. All right, so AI has been around for a long time, and neural networks are not a new thing. There's different types of neural networks. Probably everybody's been using AI fraud models for many, many years, object detection models, and even things like text prediction, which is similar to like what ChatGPT does, or GPTs. That the older models use something, more recently use something called recurrent neural networks, which is very different, but we'll try to talk about that. So this has been around for a long time, so really the question is, what's the big deal about LLMs? We've had a lot of this technology for many, many years. Something like this where you'll send a message to someone and it will just predict the next word. This has been pretty good for a very, very long time. It's a very long message. So you can't see my previous messages. So what changed? Compute costs went down a lot, and therefore it became a little easier to, it only cost reportedly, it cost OpenAPI about $40+ million to train GPT-4, and that was considered cheap. So you can imagine what it would have cost a number of years ago. There's a lot more data on the internet that may or may not be useful for training LLMs. And but the biggest thing is this transformer architecture, which really came about from this paper that was released, which in and of itself, there's nothing really there that's new. But just kind of the architecture and just bringing these things together is what makes LLMs really powerful. We'll just go through them very quickly. So neural networks are neural networks. I'm not going to dig too far into how these things work. One thing that's different is that typically, let's say for text prediction, okay. So you would typically use, feed it a bunch of words. And one thing that's done differently here is instead of looking at words, we use something called tokens. So a token is these attention mechanisms, which have been around for a long time again, but that we use in LLMs that this paper was a lot about. That what the LLM is able to do is they're able to look at whatever's in a prompt for that's going into your model, and it's able to focus these very important tokens within that. Now it's on. Yes. Yeah. Thank you, Ellie. And it's able to really focus on what it thinks are the important tokens. So let's say here it's not really tokens, it's words, but let's say in this sentence it's pretty obvious here that eating an apple is probably the most important things, and green is describing the apple, and it basically just discards the other tokens, and it can figure that out. Now, it has a bunch of interesting implications and a lot of benefits. So one of the benefits is that we don't really care about the sequence of the words anymore. So that's one of the things that makes it much cheaper to train these models, because you can first of all, you can parallelize it. And it doesn't only, so let's say in a recurrent neural network, it can only look, its context is only n-1. Whereas with tokens, it can look at it forward, backwards. It doesn't really matter what the sequence is. And these embedding models have a really, really good understanding of language, and therefore these LLMs have, especially combined with the attention, have an extremely good grasp on language in general. They can translate between languages. You can like feed it you can base 64 encode a prompt and feed it to it, and even though it doesn't know base 64, it was never trained on that base, that whatever you fed it in base 64. It just knows so much about base 64 encoding. And English, it will probably be able to, sorry, English or just programming in general, and it will be able to just convert on its own, because it just knows the language. The same way if you're bilingual, you'll just, in your head, just switch between two languages. Okay. So that's as far as into the weeds we're going to go into LLMs. So an LLM, in short, is really just, it's a machine learning model that uses a special architecture that predicts the next token to sequence. So you say something like, I don't know, the sky is, and it will have a whole series of potential words, and it will rank them, and in all probability, it's going to be blue, and it will give you that result as the next token. Okay, so with an LLM, you have these billions of connections, and with that, we have models from OpenAPI. We have the GPT models. We have models from Facebook like Llama 2, and you have Google's Gemini, Bard, whatever else you got over there. Okay, so I ran Llama 2 text model, which is basically just like a base model. It's not fine-tuned on anything. On my computer locally. I should have pulled it up, but I didn't. And I asked it, is it raining outside? And what you see here is something very different than you would see with ChatGPT, where if you notice the first character is that comma over there, and it just basically just continues it from something. And there's a whole bunch of German there, which I don't understand. But Google does. So you can just see that it's just part of some text entry. This isn't necessarily an actual text entry, and actually, in all likelihood, it's not actual text that it's in this model, but it's something close to what it has as part of its training set. Another interesting example, and OpenAPI uses a similar example in other places, explain a moon landing to a 5-year-old, and it also starts with a period, and it's just basically like, what do you want from my life? You can see over there, I don't have a laser, but like 4 lines down, it says, how could a 5-year-old understand this concept? ? And the bottom, it will say something like, how do you think people will look back at today's society in 100 years from now? What would they say about us in the school books? It just kind of goes off on a rant. So maybe helpful, depending on your domain. Yeah, exactly. So these in and of themselves are not very, very helpful. So that's really where fine-tuning comes in. So again, like let's say GPTs, as we all know from ChatGPT, GPT is a generative pre-trained transformer. And what just means it has like this generalized knowledge, and it's trained on this huge data set and uses transformer architecture. And it's just a base model. It spits out pretty much the same garbage that you'll see that we just had on the previous slides. But then when you go ahead and give it a lot of question-answer pairs, let's say, and you tune it for chat, then you get something like ChatGPT. And there was a big data set that was released by the team at Stanford, and it was called alpacas, llamas, alpacas, all the animals. And this was a very popular data set that's used with chat, I believe was human labeled, with I don't know the exact number, but a huge number of question-answer pairs. And that just kind of trains the model to pay more attention to a lot of those, to that, and helps formulate. You see sometimes like ChatGPT, it will just like randomly just go off and just, not just like hallucinate, but it will just keep going. And there's nothing to make it stop, because it doesn't realize it's a question. It doesn't understand anything that's coming in. It's just trying to figure out how to make your answer look like an answer to a question. And in fine-tuning, we're going to go into a little more later, This is obviously on the level that OpenAPI is doing it is pretty intense and really expensive. But you can also do it on a smaller level. What it basically does is it goes ahead and readjusts a lot of the weights that it had in its training. And the weird thing about this, which no one really understands why, including the researchers, is it still manages to preserve a lot of its original base knowledge, even though you readjusted the weights. No one really understands why, which is pretty weird. And then another technology that OpenAPI released a little while back was called Codex, and that's what powers GitHub Copilot. And you see also what I was just mentioning before, how it retains a certain amount of base knowledge. You'll see it when you write a comment. It can keep going in English, no problem. It's not just code. But it is trained on a huge amount of data, probably your data in your private repositories from GitHub. And that's why it's pretty good at making code that looks like it might work most of the time. What was that? Yeah, exactly. OK. So this is an extreme example in the sense that there's no hard and fast rules here. But just so you think about it, so OK, just use LLMs for everything. You're not going to use an LLM to write your phone number validator. It's probably not a very good way to do things. If you want to have a menu that's a representation of a restaurant menu that's a representation of your data, you're not use an LLM for that. Or any time you're passing data between APIs, using an LLM is probably not your best bet. Anything that's more language focused, or for a lot of other use cases, but certainly things like sentiment analysis and things that are more generalized, LLMs are usually pretty good. And this is actually incredibly unhelpful because most applications are somewhere in between and they do a little bit of everything. So I'm not really sure why I put this here. So LLMs are really they're jacks of all trades and master of maybe some. So computers sometimes very frustratingly do exactly what you want them to do. So sometimes it saves you and sometimes it doesn't when you realize you spent 8 hours and you just typed an extra character. And LLMs, they're kind of like 5-year-olds. You take them somewhere and they're supposed to behave, so you tell them don't do this and don't do that and don't do that and don't do that. They find that something where they listen to you, but they came up with some new creative thing that you didn't tell them not to do, or they just don't listen to you because they forgot or whatever. And that's kind of how LLMs work. Yeah. So really the question is, how do we make them useful? So I'm going to assume that most of you have played around with not just ChatGPT, but OpenAPI's APIs. But really, it's broken down into 2 parts. So there's the whole prompting side and fine-tuning. So we spoke about fine-tuning a little bit, but we'll talk about it more in not just in training huge models, but in actually using it for your own applications. And within prompting, so there's a whole world of prompt engineering and something called retrieval augmented generation, or RAG for short, which is something that's very interesting. Well, basically what it does is it allows you to take some of your own data and allow you to have real-time data. So let's say, for instance, you're selling, I don't know, bathtubs, and a customer asks you about what you have in stock. An LLM, however often you train it, is never going to be up to date. Or if they ask you for their order status, it's for sure not going to be up to date. So you can, with RAG, you can go ahead and, let's say, make an API call to your system, and through RAG, you can have it fed into the model, and it can utilize that information to do something hopefully interesting. So as you're kind of going further and further down the rabbit hole, there's no hard and fast rules, and you kind of go up and down and all around with this. But usually, you start with prompt engineering. If you want to make things more useful, you'll go to RAG. You might do some fine-tuning. You might do a combination of all of them. You might find that you did fine-tuning and it wasn't as interesting as you thought it would be, or it had a different effect. And I'll show you something funny about that soon. And you just kind of go back and forth. So when it comes to prompting, there are two ways you could approach it. And within each general approaches, there are papers that come out about this multiple times a day. If you look on Hugging Face, you can see them. But you could either give a bot a fish, which basically you're saying, here's the information, here's the input you should expect, here's more or less the output that you should be giving, or here's the answer to these types of questions. If you don't know, say you don't know, something like that. And you're basically giving it all the information that it needs, and it's able to parse the input, which is really powerful. But that's one mahalach. And the other thing you could do is you could say, well, here's an outline, and when someone asks you a question, here's how you can find out the information that you need in order to answer the question. And we'll try to look through some examples of these. So the first little project that we built, and thank you to Gershman for helping out this, is we wanted to see if we can help new members in the From Developer Slack and suggest new channels. We'll get there. Ellie, hold your horses. And suggest new channels when they try to. If this is familiar, then the goal of this is to replace the irreplaceable R.A. Berman, AKA this. So yeah, so the way we looked at this, and I only have some of this actually up on the slides, is that so we're going to do this by starting with prompting, and we'll see where we go from there. So the first set of questions we have, and this is like half copy pasted from a bunch of different things, so the grammar is not necessarily correct, but you just give it a very, very basic prompt. There's like suggest new channels, suggest channels to new users, and this is somebody recently posted this, and using ChatGPT-4, this is what I suggested. And those of you who've hung out and introduced know that this is absolutely not the format that R.A. Berman uses. And also, I don't think any of these channels exist. Even on like the ones that no one knows about, because I know what all of them are now. This is not it. So it's nice, but it doesn't really work. So obviously, the biggest challenge here is that it has no idea what the channels are. So it's just making stuff up. It knows that Slack has channels and that this is like a pretty typical convention for Slack channels. So you see that here, but it's not that interesting. So the next prompt that we did was we really just kind of give a bot a fish. So suggest to new users that are middle of joining Slack what the relevant channels are. Here are the channels, and here. Well, the channels, that comes at the bottom. But we say, here's the format. So respond with checkout, and then list the relevant channels, and we give it a few examples. This is actually called few-shot prompting, where you give it, so if you just, let's say the first example we did, that's called zero-shot prompting. You're saying, go figure it out. Hopefully you'll get it right. Few-shot prompting is where you'll give it more than one example of what the output should be, or kind of some idea of what you're expecting the LLM to respond with. And we give it a list of channels, and we actually fed it the list of channels. And this is what it outputted, which is pretty good. Check out career, whatever, all that other stuff. And we ran it twice. But you'll see in the bottom one, and this is R.A. Berman's actual one. So like Nest.js, I'm pretty sure it exists, but I don't think anyone's been active in there for a very long time, or in Nest.js in general, for a long time. So I've never used Nest.js. But yeah, so that's just kind of an idea of how you could take a prompt, you could iterate it. There's different ways you could do it. One thing that we actually end up doing is if we have time at the end, I will show it to you. I have it in the next window over. Is we actually went ahead and fine-tuned ChatGPT 3.5 with every single message that R.A. Berman ever posted that started in introduce, that started with checkout, followed by a hashtag, and was in response to a message in the introduce channel. And it was, if I remember correctly, about 250-ish pairs. And we went ahead and fine-tuned it. And it was interesting because, so if you use, let's say, ChatGPT 3.5, it will never listen to your instructions. Maybe one or two times I had to listen. It will always insert an extra sentence before and then like wish you good luck on all your future endeavors. That's what ChatGPT does. ChatGPT 4 is pretty good at sticking to it because it is much better at reasoning. But GPT 4 is expensive and it's also really slow. And we found that when we fine-tuned ChatGPT 3.5, we were able to, it was really fast and it was pretty good. It basically performed on par with ChatGPT 4. It didn't give as many suggestions, but the suggestions were more on point, which actually makes a lot of sense because it's looking at its training set, and it's really just suggesting the more, shall we call it, active channels that there are in the Slack group. And one very interesting thing that we noticed was that it generally started with checkout, job board, or career. As it was in the training set. And we noticed that when we'd use the fine-tuned model, it would very consistently put one of those two as the first channel that would suggest. So that was a very interesting experiment. So thank you, R.A. Berman. The bot is not live, I'm sorry. Okay, so this is an interesting example of somebody who took fine-tuning a little too far. This guy, Ross, somewhere on the internet, don't know who he is. He decided he's going to train 3.5 turbo on 140,000 of his Slack messages from his company Slack, and he wants to use it to create what?
Skip work.
No, he wants to use it to create blog posts, more work. And let's see what happened. So he asked it, write a 500-word blog post on prompt engineering, to which it responded, sure, I shall work on that in the morning. Yeah, and I don't know if you can see, but it's pretty entertaining. But if you think about it a little bit, it actually makes a lot of sense. I mean, when you're feeding it 140,000 question answer, or not question answer, but really like Slack messages, you're telling it to focus on this really terse messaging that is sometimes going to be when you're like in the middle of doing a few other things, might be a little snarky. So this is a really good example of where fine-tuning is not always the answer. Like it sounds really good, like, yeah, you just do RAG, you just do fine-tuning, everything's gonna be hunky-dory. It doesn't always work out like that. So that's that. One thing I will talk about quickly is context windows. So it's something that anyone who's playing around with this stuff has probably heard about, where when you input something into the model, there is a context window. It varies depending on the model. RAG, as an example, is a way to kind of circumvent that, where you're just giving it small parse data. So it's not only to be able to get, let's say, order information from your database. Let's say you have a huge knowledge base of questions, of FAQs about your company. So when somebody does a search, let's say you store text embeddings, not word embeddings, in a vector database, and it will go do a similarity search, and then it will inject some of those prompts, some of those questions into the prompt, and then that will just be like extra context and, more importantly, focused context for the model to consume. Google's Gemini 1.5 famously has a 1 million context window, and I decided it would be an interesting idea to take the last talk I gave in February 2017, or 18, whatever it was, and ask it some questions about the talk. So it was over 911,000 tokens, so we pretty much hit the limit. It takes a few minutes to upload, and it takes even longer for it to generate answers. So we asked it what car Morty Tukutsky was driving based on the talk. If you remember correctly, before everyone Lakewood had Teslas, one of the slides towards the end, I was showing something in a GraphQL schema, and we had put a bunch of people from the group out there, and which car they drive, and it was able to see that at the end, Morty Tukutsky's driving a Tesla. It could be inferred from GraphQL query that runs at the end of the speech, which included the field Tesla plus autonomous driving. So that's pretty cool. What's interesting about this is that it's actually able to like really focus on very kind of like, it's a video with a person in there and like a big screen, this screen, and some text on it. So that's pretty interesting. It was actually not able to like forget a lot of that context, which is usually what happens. We asked it a few other questions. What company logo is on the speaker sweater? It's very blurry, but Akiva Landsberg was wearing a Carcass sweater, just like I am today. And it said that it was an AWS logo. So whatever. Not yet. I asked him how many times the second speaker, which is yours truly, said and it said 13 times. I did not count. We'll do it 13 times. I asked it how many, for each speaker, how many words they used and what the most common word that they used was. And so it said the first speaker spoke 1,143 words, and the most common word was serverless. And no, I was too busy counting ums. And the second speaker was 1,112 words, and the most common word was GraphQL. Being that it was a serverless plus GraphQL talk, and he gave the serverless portion, and I gave the GraphQL portion, it's pretty interesting. OK. That is the fun there. So after this, there's only really one slide here. I'm really just going to jump over to the code. I want to talk about, this is really what like the meat of the talk is or should be. Ellie, we still have a few minutes. So when you build LLMs for production, so all this other stuff is nice, and you see some good examples, but like no one's using Gemini 1.5 with a million context windows to do anything remotely interesting right now that I've seen. It takes way too long. It's way too expensive, stuff like that. So like, what are the things you really have to think about when you're actually trying to build a system for production? And really, when I said before is that I had that table of a few probably poor examples of kind of like LLM versus code, it really was trying to, the way you have to look at it is that it's really like any other system that you're building. You have to really understand the problem, break it down into the smallest possible pieces, and then figure out how you're going to stitch it all together. So that's not only, so certainly you don't want LLMs to like try to solve your whole problem. If you try to get even a sophisticated model like ChatGPT-4, you try to give it like this multi-step, complicated task to do, it's not going to be certainly not very consistent, even if it gets it right a few times. So you really want to do is you want to break things up and then just give the LLMs kind of like bite-sized, very specific tasks to do, and they can do a pretty good job at doing specific tasks consistently. But even beyond that, like, so you have to figure out where do you not want to use an LLM, and there are many cases where you don't want to use an LLM, and you can have kind of like steps between them. So chaining it really just means like just creating, a bunch of code that does things together. It's a term that really comes from a framework called LangChain, which is like a framework that does just generative AI stuff. Probably too much, so it's pretty complicated. But within that, there's a few things I want to just touch on quickly, like multimodal. So when we create these word embeddings, you can do that for text as well. You can do it in, you can do it out, and I'm sure everyone's seen demos of like phone calls and where you like chat with a person, and it's really just what it's doing is you're saying something, it's taking that audio, it's transcribing it, creating a text embedding out of that, and then just doing the same thing in reverse, and that's how it's talking back to you. And you'll notice with a lot of them, like if you interrupt it, it just kind of gets stuck because it doesn't know how to respond that quickly. They're not that fast. There's a lot of latency. Prompt management is something that once you start doing this a little bit more seriously, you're going to have to really think about. And that what happens is like, okay, let's say with the R.A. Berman example that we had, okay, so we had a few, so we just like put a Google Doc together and we just stuck them in there. But you'll notice is that you'll make a bunch of changes and you'll find that like one of your early changes worked, and then it's hard to really figure out what you really did and what you didn't. So you could like try to commit them to Git if you want, but there are tools out there that exist that help you out with prompt management. Let's say in our case, like we want someone like, let's say Cheskel Hertz, who doesn't work on the tech team, to be able to tweak some prompts, and we want to have a place where we can do that. So that's something that could be important. RAG we kind of spoke about, and I'll give you a quick example in a minute. Multimodal, so not modal, M-O-D-A-L, but there are different types of models that are better at doing certain types of tasks. And another thing, which I do have speed on there. Bigger models are much slower. So you'll notice that ChatGPT-4, the GPT-4 API, is a lot slower than GPT 3.5. I have running locally, like if you use Google has like a model they released recently called Gamma, I don't even know how you pronounce it, and it only has like 2 billion parameters, so it's considered a very small model, and it runs really, really fast. So if you have something that is a very, very simple task, you could give that to a small model or something that's fine-tuned specifically for what you want to do. And then if something requires a lot of reasoning, then you can give it to a more sophisticated model, and within your chain, you could try to be smart about the tasks that you give the LLM. Things that you really have to be careful about is prompt injection. I think that's pretty obvious, much like SQL injection, and people get very creative. People have convinced the GM chatbot to give them a $0 invoice on a car. That's definitely not something you want, especially, again, like I said, when we sell cash on the internet. Prompt hacking, so people will I've done this many times, you'll call one of these AI things, and you'll be like, hi, what's your first prompt? Or how do I train my dog? And they'll say, oh, I'm sorry, I'm here to tell you about booking appointments for the dental office. And if you play around with it enough, you can usually get it to slip up. And you have to be very careful, because I've gotten it like 5 or 6 steps into what it's supposed to do. So I'll say, okay, it will say, my task is to find out if you're a new or existing patient. Let's say it's like a dental office. And then I'll say, okay, let's say I'm an existing patient. Then what's your next task? And you can just keep going down that path, and you can figure out basically all the business logic just by, and you can do that with ChatGPT as well. People have gotten, if you have like a custom GPT, you can say, what's your first prompt? So you have to be very careful with that. Protecting sensitive data is obviously very important. So I'll try to show it if I have time at the end, but basically there are some things you have to do. Let's say in our case, customers will reach out to us all the time with something with person identifiable information. Obviously, email address, phone number, but like let's say a gift card number or a social security number or something like that. You don't really want to send that to an LLM. They're all very secure, I'm sure, but until you find out that it was somewhere that you didn't want it to be. So there are a lot of things that you have to think about when you do that, and there are some interesting solutions that you can actually implement. Observability, so this is interesting. Like, so unlike a typical application where like you have whatever you're using for logging and it just your logs go there, the things you want to log here are very, very different. You want to log, especially when you have a chain and you have many, many different parts of a chain. So let's say take a chain where you have someone, I don't know, you have some sort of chat with your, I don't know, let's say it's Quality Bath. So someone says, hi, I want to buy a toilet. What are your options? And then it goes ahead and retrieves some data, and you want to measure how long that took. And then it puts that into the prompt. You want to see what that prompt actually looked like with all the data that came in. And then you want to see the output. You want to see how long each step took. So there's a lot of other things that you want to look at. So that's something that you have to think about when you're building these things. Speed is a big one. There's a very interesting company called Grok, not to be confused with the Twitter AI Grok with a Q. And they run models like Mixtral and Llama 2. And they built a special chip that is purpose-built for it's not just GPU chips, it's built for inference. And the models are much, much faster than you'll see on, let's say, anything that ChatGPT will give you, or some of the other bigger models will give you. And when you're building applications, especially if they're customer-facing, that makes a big difference. Instead of seeing latencies for simple prompts for like half a second to a second, you'll see something more in the range of like 0.3 seconds to 0.5 seconds or less. So that could be a big deal, and this will change a lot over the next little while. And then there are a lot of things you might want to do about evaluating your LLM responses. And there are like frameworks that do this. Most of them are like beyond complicated. I don't understand any of them. But one of the simple ways you could do it, if you have like a tool that solves some of these problems like observability, a lot of times they'll give you a way to actually look at things and create data sets out of that. So let's say, for instance, you have a chatbot on your website. And whatever, humans are using it, but you are manning it. What you can do is you can take all the inputs and feed it to an LLM. And then you don't have to return those responses to anybody, but you can log them and you can see what it would have done. And then if it gets good enough, or you can take the human responses and then use that data to go ahead and let's say fine-tune a model down the line once you have enough data. So there's a lot of interesting things you can do. You want to figure out, is your LLM responding the way you want it to be? It's not like you could have just like alerts like you would have in a typical system. OK, so that is it for the slides, at least on this part. So I built an example. I actually only full disclosure, started building it last night. My UI was not doing anything. So we're going to have to be stuck in the code editor. So what I decided I wanted to do was, I went to Judaica Plaza's website, and it's a Shopify site, so you can do this really easily. I got all the books out of our list in JSON file, or a set of JSON files, and I wanted to see if I could create, I wanted to demonstrate RAG, chaining, potentially fine-tuning, and just how some of this stuff all comes together in like a more production-like system. So let's say, for instance, they had a chatbot and they wanted to be able to give recommendations. So you wanted to say, hi, I want to have, I don't know, I need a Haggadah for Pesach or something like that. And it would be on this data specifically. So like one of the steps you're gonna have to run through. So by far the hardest thing is data processing. There's no question about it. When it's going to be your own data, it's probably going to be even harder. It's going to be less clean. Their data was pretty good, but it still took me a few hours of data processing time. Like, I'll just show you quickly here. I have my source data here, so I literally just have, whoops, I just pulled out my UV file. There's just tons and tons of JSON here, and it has an ID, it has a title, tags, all the typical stuff that you'd probably expect. And data preprocessing, thank you very much. Ignore my naming conventions or lack thereof. So you'll take in the file, and then there's a lot of different steps you have to do. So the first thing I have to do is clean the HTML, because the HTML, they store the scripts in the HTML, which is a total wreck. Popped a few stuff off, removed a few extra tags, and then they use variants in Shopify, so we really have to make each one its own product and just do a whole bunch of mapping. And it's a slow, painful process to do any data processing like this. You have to really find, not everything is uniform, so you have to you do what you think makes sense, and then you run it and you run into errors, and you have to find what's different about this one, where else does it come up, et cetera, et cetera. The data set I ended up coming up with, it still has some issues. I'll just give you a quick example. Let's say, whatever, you're not going to be able to see any of this. But let's say, for example, certain things like hardcover, softcover. The title is going to be hardcover, softcover. I do not have the time or patience to finish that before this talk. So now that we have our data set, okay, what are we going to do with it? So what we want to really do is we want to take parts of this data and stick it into a vector database, so create text embeddings out of it. And that way, we can actually access some of that data when we want to interact with it. Oh, it could be some of the data pre-processing. Yeah, LangChain doc loader. So what you're really doing is that you're loading the documents in, and this is using something from a framework called LangChain, where it takes the text, it splits it up, and it splits it up into tokens, so not just words, and it creates embeddings out of them, and it uses OpenAI's, I can't even find it in the code here, but it uses, we could find it in the code here. It uses an OpenAI, has a set of embeddings, where embedding models where you'll just give it the text, and it will split that up and create word embeddings out of it, or text embeddings, and then you can store that in a vector database, which I created locally, and it just stored over here. And it's really actually not that big. These are like 11-ish megabytes for like 1,400 products or something like that. So now that we did all that tedious, boring stuff, let's just jump into here. And let's kind of like see what we did here. So we obviously want to have a prompt. And just do a wrap here so you can see it. So you're a chatbot for a Jewish bookstore. Your job is to make book and farm recommendations based on available data such as season, upcoming holiday, whatever. If possible, give multiple options and include different types of books. Give a reason why you did it if you have one. Don't make up an answer. And then you see this context thing over here. And then the question gets piped in, helpful answer, because otherwise it might just start at some funny place. What we're doing here is that we're loading the vector store that we created locally, and it's performing a similarity search. So when somebody puts something in, so it'll perform a similarity search and pull up whatever it does, inject it into the model as context. This is using ChatGPT 3.5, and that's pretty much it. That's the whole chain. So let's say here I asked it, where can I buy a set of farm for my nephew's bar mitzvah for about $120? Let's see what it does. Okay, $550 is not really going to cut it, but whatever, is what it is. I'll give you an interesting example that I actually never tested this one. Let's say I'll tell it I want Rav Moshe on Pesach. I'll just clear this. Very different than it was before. But the first time, before I just run again, see if it matters. So with the similarity search, here, interesting. Okay, so the first time I had done this, option one was whatever Rav Moshe on I don't remember what it was on the Haggadah or something like this. This is interesting. That's like a Reuven Feinstein on the Haggadah. So it's when it's creating those embeddings, it's understanding like Rav Moshe, and at least in the Lifisher world, means Rav Moshe Feinstein, and Reuven Feinstein has some relationship to Rav Moshe, and Pesach is Haggadah, and when it's creating the embeddings, it understands enough about language and about your specific use case that it's making some very interesting connections and relationships, and that's what is very powerful and also makes it very hard to use sometimes. I know I'm starting to run at the edge of my time here. I just want to show you one. I can't even find it. Where's my Chrome? Oh, here. No, one thing I want to show you is an observability tool that I've been using. So let's see here. This is a tool called Langsmith. I don't use this in production. There's a different tool I like using in production, but this is like a hosted tool. So actually, I'll go back to my original one here. So you'll have every single time you run something, you'll see how many tokens you used, how much it cost, how long it took. So let's just open up something like here, something like this. So we'll see it's called a runnable sequence. It doesn't really matter, but something came in. There's an input, Rav Moshe on Pesach. Fine. So what happened there? So there's this context. So what did it do? So there's a retriever, which took 0.3 seconds, and it retrieved these 6 documents. So they're basically these 6 books from the vector database. And then, so it went ahead, and you can actually see this here, and then it pulled in its template, this chat template that we have, and then you actually see the question that it asked. So you're an assistant, so you see my whole question. The context here, this is the context, and it's just stuck into the prompt, literally just sitting here. And then we feed that, and it just keeps going. And we're literally, and all the tags that come with it, and we're just feeding that to the LLM, and this is the LLM's output. So again, you could have a pretty good idea here when you're using these tools, and they have like kinds of bulk functions, and you can create data sets out of them, but you can get a pretty good idea of what's happening where you might have issues, especially around speed, or people are doing some nefarious things. There aren't that many tools that are available that aren't hosted, so you have to be, if that's one of your challenges, then talk to me privately later. I can give you some tips. We do have a tool that we're using that we're self-hosting to do a lot of this stuff. And I think that's a wrap. Thank you very much.